Okay, so this unit is on writing chemical formulas. Well, it's on chemical formulas overall. The first half will be on writing chemical formulas. So go ahead and title your section that, and we will kind of begin. We're going to begin with a little bit of review. All right, if you remember this very well, then you do not need to rewrite this. If you do not remember this very well, write it back down. So remember that cations are the ions with a positive charge. They lost their electrons because electrons are negative. That makes them positive. Okay? The anions are ions with a negative charge because they gained electrons. All right? That is review. So if you would like to write that down, go ahead. And guys, even though I am recording, if you have a question, go ahead and ask a question. They probably won't pick up your voice, and I will not call you out or something. Okay? All right. There, we got it? Okay. All right. So this first part, and this is what we're going to focus on today, is writing formulas for binary ionic compounds. Writing formulas for binary ionic compounds. So label this section of our notes, writing formulas for binary ionic compounds. Okay, those of you know number theory a little bit, what does binary mean? 2. In numbers, it's 0, 1, which is just 2 things, all right? And that's what this is going to be. Binary ionic compounds are made of only 2 elements. Because it's ionic, it's charged particles, okay? And these will be made generally, almost always, I can't think of an exception, of a metal and a non-metal, like we learned in the last unit. Ionic compounds are generally metals and non-metals, so if it's binary, it definitely is. Once we get into a little more complicated, which will be tomorrow, they could have some more than one non-metal. All right. A key concept of this is that the overall charge for the compound at the end, after we've written the formula correctly, the compound must come out to be 0. Okay? The charge must come out to be 0. So those are some of the things about writing formulas. Anytime they're ionic, it should come out to be 0. Now, when we get to the test over this unit, most of it will be practical. There may be a handful of concept questions like that, but most of it will be just writing the formulas and or writing the names. All right. Oh, no, I see a couple people still writing, so we'll give you a little bit more time. Okay, we'll move on. Okay, whenever we have compounds like this, the cation or the positive ion is always written first, and it will be listed just as its name. The anion or the nonmetal will be written second, and they change the ending of the nonmetals to IDE. Because I have in the past ran into people saying, is chloride just chlorine? Yeah, it is. Well, it's chlorine in a compound, all right? Sulfide, nitride, oxide, they are in compounds, and generally will have their negative charge. Okay, and we will talk about the negative and positive charges here in just a second. Guys, if you finish your notes, go ahead, or finish this notes up, go ahead and grab your periodic table out. The one you color coded. We're going to add some more information to it so that you can use it on, again, this test and the rest of the tests for the rest of the year. Okay. Before we go on and do our first example here, guys, I want to show you what I would like you to put on your periodic table. Oh, I'm sorry. No, you're fine. I apologize. I thought I'd seen everybody's pens down. Guys, if you are done with your notes, please don't start talking because it will be picked up as dull noise on the microphone. Okay, are we good? Okay, you're fine. Gotcha. All right, so on your periodic table, guys, if you remember, the first column all has one valence electron, correct? You remember that from last chapter? Well, some of you guys did. Some of you, maybe not so much. But is it going to be easier, or, well, let's back up. How many electrons do they want according to the octet rule? 8 valence electrons. Is it going to be easier for these to gain 7 or lose 1 and fall back like the row before? Lose 1. So when they lose 1, you subtract a negative, which makes it a positive. Everybody in the first column will be plus 1. Everybody will be plus 1. So if you want to write plus 1 on top of the first column, you can. When they form ionic compounds, they will be plus 1. The second column will be plus 2. Plus 2, because they have 2 valence electrons, they're going to be easier to lose 2 than gain 6. All right? We're going to skip the transition elements. They have special rules. Okay? And we're going to go to group 13 or 3A, and they have 3 valence electrons, so they will lose those 3 and become plus 3. Now, I believe thallium and maybe indium have some exceptions, but we don't deal with those a lot. And if we do, I'll show you how to handle that. All right, column 4A, they're right in the middle. What does that mean? For the most part, at least the top 3 hardly ever form ionic compounds. They're going to form covalent compounds. We'll talk about how to deal with it later. The bottom ones down here, again, like thallium, there's a special way to deal with that, and I will show you that here in a minute. Then we get to nitrogen. Nitrogen has 5 valence electrons. It's over the halfway point. Is it going to be easier to lose 5 or gain? Gain 3. So it will be, yes, minus 3. Oxygen has 6. Is it easier to lose 6 or gain 2? Gain 2, and they're negative, so everybody in this column will be negative 2. So you can put negative 2 above it. And then fluorine's column. Fluorine is got 7 valence electrons. Easier to gain 1 or lose 7? Gain 1, so it's going to be negative 1. The noble gases already have the noble gas configuration, so they rarely form compounds, and when they do, it's covalent ones. And it's only xenon and maybe krypton, and I think it takes like special scenarios. All right, are you with me on that? Now, before we learn how to deal with the middle guys, there are 3 of the middle guys you need to always know. Zinc, number 30, everybody find zinc. It is always plus 2. The rest of these guys can generally have more than 1 charge, but zinc will always be plus 2. Cadmium is always plus 2. Zinc and cadmium, always plus 2. And silver, always plus 1. Zinc plus 2, cadmium plus 2, silver plus 1. Are you with me? Okay. The rest of these guys, I'm going to show you how they deal with it. They have to tell you what their charge is in the compound that they are in. And we'll see that in just a second. Okay? All right. Any questions on the periodic table? All right. Let's look at our first example. Magnesium chloride. Okay? So like I said, the magnesium, they just tell us what it is. The chloride, for some reason, they feel like they have to change the ending. So that's fine. Okay, hang on. All right, don't get ahead of me. If you are, that's great. But if not, hang on. All right, so magnesium is Mg. All right, if we look on the periodic table, okay, it's in the second column. So what would be its charge? Plus 2. Okay, chlorine is Cl. Now, when you're writing lowercase l, I know you guys, most of you don't know cursive. But to keep it from being confused with CI, write the lowercase cursive L, which is a little loop. Kind of looks like the cancer ribbon, right? Okay. Okay. If we look at chlorine, it's in this column. So what's its charge? -1. All right. The key thing is, and remember we drew these out and we had to keep going back and forth, but now we can do it with math. The key thing is it has to come out with 0, right? We can use something called least common multiple. What's the smallest number 2 and 1 can both go into? 2, right? What's 2 divided by 2? 1. So I'm just going to have 1 mg. And what's 2 divided by 1? 2. So Cl2. All right, because 2 times -1 would be -2. -2 and +2 would be 0. That's what we have to come out to be. Are you with me? And look, I typed all that out. It made it really pretty, and it still works. I know. A lot of typing for me. All right. Okay, let me do another example here. Okay. All right. Now, this one is got to do with the transition metals. The ones that I did not give you. Remember, I gave you zinc, cadmium, and silver. For every other transition metal, they will indicate its charge with a Roman numeral. The Roman numerals are always positive. If you want to add that there, you can. Okay? So the transition metals, the metal's charge is indicated by a Roman numeral. All right? By a Roman numeral. Okay? So, if we look at one like this, I should have chose a different charge because it's going to come out to be similar. Okay, all right, bless you. All right, so copper 2 chloride. Okay, all right, so copper is going to be one. If they give us the Roman numeral, then we know it's going to be a transition one. If you don't know copper, hopefully you do from our quizzes last semester. Copper is Cu, comes from the Latin, I think, cuprum. All right. Huh? Oh, okay. So copper is +2 again. Chlorine, we already did chlorine, is -1. All right. So I'm going to need more chlorine again. It follows the same pattern. So this one would be CuCl2. Does that make sense? Is that super difficult? Let's do one that's just a little bit trickier. All right. I don't have this one typed out, so I'll wait till you guys get this written down. Let's go green. All right. It's okay if I go ahead and slide up so we have a little more room. All right. What we're going to do is we're going to go gallium selenide. Oh. Gallium selenide. So if we find gallium, what's its symbol on our periodic table? Ga. And what's gallium's charge? Which column is it in? Yeah, it's in this column here. So it's going to be +3. Now, selenide is one. We got to figure out what element it is because remember they changed the ending. Selenide is going to be selenium, which is Se. Okay, and selenium is in the same column with oxygen, so it's going to be -2. All right? Now, not worried about their charges. What's the least common multiple of 2 and 3? 6, right? What's 6 divided by 3? 2. So it's going to be Ga2. And what's 6 divided by 2? 3. That's all you got to do? Is that super difficult? Now, like I said, thallium, tin, and lead, they kind of follow the same rules as the transition. So if they're talking about tin, they might have like tin 4 or something like that. Now, real quick, and you can put these, if you don't know them, you can put these, oh, I thought I had these on here. Maybe I did not. Oh, my bad. All right, let me give you the Roman numerals. You can put these on either your polyatomic ion sheet or on the back of your periodic table. Does everybody know the Roman numeral for 1? It is I. Does everybody know the Roman numeral for 2? I. All right, Roman numeral for 3? I. Roman numeral for 4? IV. So it's 1 before 5. So what is 5? Just V? Roman numeral 6? VI. So 1 after 5. All right? And then 7? VII. Okay, so you can either put that on your periodic table, maybe on the back or something like that, or on your polyatomic ion sheet, and you can use that. Now, you will never have a charge greater than 7. All right? Because if you get to 7, the next one's 8. If it's already got 8, it's going to be happy. Really, most of our charges will be 1 through 3. You will have occasions of 4 and 5. All right? But they're rarer than 1 through 3. But if you ever came up with one and it's like 9, no, you can't have a 9. All right? Any questions on this? Okay, I'm going to go ahead and stop the video. I'm going to hand out the assignment.